Hey everyone, so in today's video we're going to be going over Gay-Lussac's law. So Gay-Lussac's law describes the direct relationship between pressure and temperature of a gas at a constant volume. So the equation is P1 over T1 is equal to P2 over T2. P1 and P2 being the initial and final pressure, and then T1 and T2 being the initial and final temperature, both in Kelvin. So an important note, we need to always convert temperature to Kelvin by adding 273 to any degrees Celsius we get in a question. So let's go over the first problem here. A gas has a pressure of 1.2 atmospheres at 300 Kelvin. What will the pressure be at 360 Kelvin if the volume remains constant? So first, let's write out our equation. P1 over T1 is equal to P2 over T2. And we want to isolate for P2, or the final pressure. So P2 is going to be equal to P1 times T2 over T1. And then now we can simply sub in our values. So our initial pressure is 1.2 atmospheres. Our final temperature is 360 Kelvin. And then our initial temperature is 300 Kelvin. And when we plug this into a calculator, our final pressure is going to be 1.44 atmospheres. Let's try another problem. A gas is heated from 270 Kelvin to 350 Kelvin, and its pressure increases from 95 kilopascals. What is the new pressure? So once again, let's write out our equation. So P1 over T1 is equal to P2 over T2. So now, once again, we're isolating for P2. So P2 is going to be equal to P1 times T2, sorry, not T1, over T1. And then now we can once again plug in the values. P2 is equal to the initial pressure, which is 95 kilopascals, the initial temperature, the final temperature, which is 350 Kelvin, and then the initial temperature, which is 270 Kelvin. And when we plug that into a calculator, our final pressure will be equal to 123.15 kilopascals. So a few common mistakes to avoid: using Celsius instead of Kelvin. Make sure your temperature is always in Kelvin. Forgetting to isolate for the correct variable. Make sure you're isolating the correct variable and using the correct order of operations, and not keeping volume constant. So whenever we're using Gay-Lussac's law, we always assume that the volume is constant. I hope this video helped. Thank you.